Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman. Hey, Ben, how are you?
Hey Simon, hey fellow Econauts, how's it going? Today we're touching the sun.
Today we are talking about the Parker Solar Probe, and my first question is, what is the purpose of that probe?
We want to study the only star we have in reach, and that is our sun. And the Parker Solar Probe is the first spacecraft to go as close as possible to the sun. And you have to imagine the sun obviously is very hot, and for this purpose, the probe has an installed heat shield that can protect the probe like from the high temperatures more than 1400 degrees Celsius.
What mysteries about the sun is the Parker Solar Probe about to solve?
Well, although you might think that we know almost everything about the sun, that is far off the reality, really. And although we have really good theories, and they are also backed up with lots of evidence about certain aspects, for the real deal, we need to measure as close as possible. And what do we want to solve? To answer your question, first of all, we want to understand why the corona is hotter than the sun's surface, and also is it really hotter? So we also want to measure that. Second thing we want to find out is what drives solar winds, and that is important to understand solar weather, space weather. We had an episode about that, but yes, space has weather. It's not like, rain cloud or something like this, but we need to understand the appearance and the strength of solar winds and be able to predict that helps to secure and protect our space assets, such as GPS satellites and so on. And also we want to understand how solar storms form and how they travel. And this is also, again, important for understanding space weather.
You already mentioned the heat shield, but there are, of course, other conditions like radiation, for example. How does the probe survive all those hostile environments?
You mentioned the heat shield, and I mentioned the heat shield before. It's a 4.5-inch thick carbon composite, and that reflects most of the sun's heat, keeping the instruments of the probe at a normal operational temperature of 30 degrees Celsius. Also, there's a special probe for the solar probe made of tungsten. The tungsten is a material that can also withstand very, very high temperatures, and also is has other rare earth materials embedded to make it resistant for this kind of heat. And also the last thing in this, everybody thinks maybe of the physical, heat shield and thick or cooling systems and whatnot. But because of the radiation, you pretty much have no way to communicate with the probe as long as the probe is actually close to the sun. And also I say that because the probe is not, you might think in your head it's just going towards the sun all the time and getting closer and closer and closer and closer. The probe is also orbiting, so it's getting away from the sun and then getting into the sun's orbit. And every time it does that, I think it will be around 21 times or so, it will get a little bit closer to the sun's surface. So that's how it works. But every time when you are in a close proximity of the sun, and close, I mean, we are still talking millions of kilometers, but every time when you're close to this, you lose your connection. Like, you can't send any signals to it anymore. And for that reason, you need autonomous navigation and autonomous command and control for the probe.
What discoveries has the probe already made since launch?
So far, we found out the origins of solar winds, opposed to the belief that the solar winds have a continuous flow. Now it has been confirmed that they are generated in small and energetic bursts. Also, the probe discovered that there are magnetic switchbacks. That means there are some zones where the magnetic field reverses in the corona, and that could also explain how energy moves through the corona. And also, there's a dust-free zone. So the probe confirmed that for a long time it has been theorized that there's a region where, in the proximity of the sun, where interplanetary dust is vaporized so intense that there's actually no dust available anymore. So this has also been confirmed now.
Why is studying the sun so important, not only for life on Earth, but also for space exploration?
Astronomy and any space discovery where we send probes is important to understand our solar system better, the origin of the sun, the origin also of planets, what is outside of the heliosphere, and so on. So these things are important. Why? Because when we know more about our environment, we can also use the environment better. So this is definitely one thing. This is maybe a bit more scientific, a bit more research, but the main interest is to understand space weather. And I mentioned that before. Space weather affects all our space assets. Space weather also affects our ground assets that are connected to space, such as ground stations. So understanding how solar winds work and being able to predict them helps us to protect our space assets. And that includes also astronauts. So when people are on the ISS, for example, and they plan to go out to repair something, you don't want them to be outside when there is suddenly a sudden outburst of solar wind, because that can have severe consequences, let's put it this way. So you don't want that. And last but not least, we want to understand, and I always preach this, understanding space makes us understanding also things on Earth. Solving space problems solves problems on Earth. Understanding the sun helps us to understand our own climate as well. And I think this is quite important, to predict what is happening in the next couple of decades, to understand where our technology should be developed.
Touching the sun has never been so interesting. I hope you like this episode, and if you do, please don't forget to leave a like and subscribe if you haven't already.
And if your finger's not burning from touching the sun, click this notification bell so you never miss out on a new episode anymore.
And I hope I will see you next time. Have a good one. Bye-bye.
See ya.